In this video, we're going to talk about x, x squared, and x cubed. What do they mean? Well, we can draw some pictures to represent each one. First, just x all by itself. We can think of this kind of like a straight line with a length x. It doesn't have a width, it doesn't have a height, it's just a straight line. It's something like the edge of a table or a piece of string, a piece of rope, a measuring tape. If you ignore that there's usually a width to the measuring tape, it's just like a long line. Next, x squared. We can think of this more as a two-dimensional shape. So a two-dimensional shape could be a square, and to get x squared, it would have a length of x and a width of x. You probably remember from past years that the area of this would be length times width. In this case, it's x times x. It can be a little bit confusing to have x's and times together. So sometimes we do x dot x, and that means x times x. Sometimes we just do brackets. But the best thing to do is to simplify this. X times x. What does that simplify to? Is it 2x? Is it x squared? Well, that can be a little bit confusing. So let's do a similar example, something that you might be more comfortable with. What if it was 4 times 4? Is that 2 times 4, or is that 4 squared? Well, 2 times 4 is equal to 8. We know 4 times 4 is 16, so that's not going to work. 4 squared. Well, that actually means 4 times 4, and 4 squared is equal to 16. So that makes perfect sense. So 4 times 4 is equal to 4 squared. What about 5 times 5? Well, we learned in the last unit. Again, 5 times 5 is 5 squared. So if we go back to working with x's, now that we remember what happens with numbers, we can think about what happens with x's. Something times itself is itself squared, so x squared. So when we're thinking of x squared, we can think about a square with length and width x. Now our third one here, let's pick a new color to work with. How about orange? Hopefully that's dark enough. Let's go down here. So x cubed. We can think about this by starting with a square with length and width x. So now we have x times x. X cubed is actually x times x times x. So we need to add one more dimension. So now we have x cubed is equal to x times x times x. You can think of it like volume. If you were trying to find the volume, it would be length times width times height. X times x times x. If we had an example where the length, width, and height were all 3, then we would have the volume is 3 times 3 times 3. We know that's the same as 3 cubed, which is equal to 27. Okay, so you can think of them, these three things. X is like a one-dimensional thing, a string, a line. X squared is two-dimensional, 2D, so like a flat cartoon, the surface of a table, a wall, anything that has a flat surface and you don't take into consideration the height of it. You would do the surface of the wall, but not like the thickness of the drywall behind it or anything like that. You're just talking about the surface, a super skinny surface. So you could do a tabletop as an example. A square, just like the area of a square. An x cubed. So x cubed is three-dimensional. That's the world we live in. We live in a three-dimensional world. You take up three-dimensional space. You have volume. So in this example, I'm mostly looking at cubes. Maybe you have a table that's very much a cube shape. The length, the width, the height, they're all similar. So it might be the space that's taken up by a whole table. Maybe you have like an ottoman in your house that's a perfect cube. That would be a good example. Okay, so now we have a basic idea for x, x squared, and x cubed. Let's look at a couple more examples. What if I have a line and it's made up of three x's? X plus x plus x. How can we simplify this? Well, we just said you have three x's. 3x. Now, if you don't really believe this, if you don't really trust it, the best thing to do is to always think up a similar but simpler example. So if the x's are confusing you, make an example with numbers. 4, 4, 4. If I was trying to figure out the length of this, I would do 4 plus 4 plus 4, and I would get 12. If you want to think about the step in between, there's a shortcut for repeated addition, and it would be 3 times 4. And that's exactly what we did over here, 3 times x, because there's 3 of them. Okay? So that's how we can work with an x by itself. What if we had an example with x squareds? What if we had a square and it had an area of 4y squared? What is the length of a side? Sometimes we want to show it's a square and we can do this. You can assume here that we're dealing with squares and cubes. Okay, so what is the length of a side? So we have to have something times something times itself, actually. Something times itself is equal to 4y squared. So what times itself equals 4? 2 times 2 equals 4. Now the next part, what times itself equals y squared. Y times y. So now we know 2y times 2y equals 4y squared. What is the length of a side? So the length of a side is 2y. It's always a good idea to write a sentence at the end when you've had a question with words. It makes it very clear. If you left just this line for your final statement, your teacher wouldn't know what you consider your answer to be. Do you think your answer is 2y times 2y? Do you think your answer is just 2y? So it makes it very clear when you write a sentence. And if your work is very messy and your final answer is hard to find, it's also a nice idea to put a box around your final answer to show that you know that's your final answer. You can also write a little symbol like this in front. It means therefore. And usually for the very last thing, we write therefore the answer is da 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 2y, and this makes it very clear as well. Okay, let's do an example with a cube shape. So think about what a cube shape looks like. I'm going to just make this space a little bit bigger. So if we have a cube, you'll get really good at drawing cubes, don't worry. If you have a cube and the sides are, let's say, 4a, what's the volume of this cube? We could write 4a times 4a times 4a, or just 4a cubed. So how do we deal with this? 4a times 4a times 4a. This can be a little bit confusing. What do you do with all these letters and numbers, with all these constants and variables? Well, let's deal with the numbers first. Multiplication can be done in any order, so we could do 4 times 4 times 4 first of all, and then worry about a times a times a afterwards. That looks pretty messy, doesn't it? This is really 4 cubed, and that is really a cubed. Well, we can do something with this 4 cubed. We can do 4 times 4 times 4. Oh my goodness, can you do that in your head? 4 times 4 is 16. 16 times 4. I think it's 64, but I like to write it out just to be sure. Okay, so it is 64. So we have a final answer. I'll just put a little box around it so it's really obvious. So the volume of the cube is 64a cubed. So there's a variety of different things that you can do with these types of questions. But try to remember that just a variable all on its own, it's like a line or a string. And a variable squared, like x squared, that's area, that's a surface, a flat surface. And a variable cubed is like a three-dimensional shape, something that has volume, something that takes up space. Those are the key things for you to remember. And also, here's a little shortcut for you. If you have a two-dimensional shape, if you have a square and its area is x squared, then its side length is x. So it's the square root. So the side length is the square root of the area. So if you have an area say the area is B, the side length is the square root of B. You can find the square root on your calculator, and you can also have a few memorized. I think it would be a good idea to have the square root of 4 memorized. That's 2. 2 times 2 is 4. The square root of 9. What times itself equals 9? That's 3. Square root of 20. Oh, I skipped one. Let me do square root of 16. What times itself equals 16? 4. Square root of 25. What times itself equals 25? 5. So being comfortable with these would be really helpful.